So we're going to go ahead and talk about angles and radians. So angles, they can be said to be in standard position when the vertex is at the origin, so 0, 0, so right at this point right here, and when the initial side is in the positive portion of the x-axis, so that's all along here. Wherever it ends is called the terminal side. So as long as that initial side is along the positive x-axis and the vertex is starting from the origin, then that angle is said to be in standard position. Now, typically, by default, we go counterclockwise. So if you take a look at that picture here, 0 starts on the far right. I go up to 90 degrees, come back down another 90 to get to 180, go another 90 to get to 70, one more 90 to get back to 360. Remember, 360 degrees means full circle, so I'm basically ending where I started, back at 0. So if I go that spin direction, and again, this direction is counterclockwise, then my angle measure will be positive. But if I spin the other direction, so clockwise, we're going to say that that angle measure is negative. And I can spin this more than 360 degrees. I can spin around, for example, 1.5 times. Or I can go clockwise, negative, 1 circle, 2 circle, and a quarter more. And so we'll look at those examples in a moment. Right now, I'm going to show the examples from the actual textbook. Then we'll go ahead and give some extra examples of my own. So this first one says, let's just draw an angle in standard position. Let's start with the angle, having the positive measure is 240 degrees. Now, first of all, come back to here, 0, 90, 180, 270, 240 is going to be in this direction here. Also think of that gap from 180 to 240, I am missing 60 degrees. So if you come take a look at what they did here, they said, okay, that full 240 says go 180 and then go 60 degrees more. So that direction of the angle, and that's my terminal side, that is 240 degrees. This next one says, let's take a look at 500 degrees. So this means I'm spinning around more than 360. So if you look at their note here, they said in the red, start here, spin all the way around once for 360. And they said, well, how much more do we need to go? 500 minus 360, so I'm taking away a full circle. When I do that, I'm still going to be left with 140. So I'm spinning this direction, and then I go 140 degrees more. So it's sitting right here. In that next one, they say, let's look at negative 50 degrees. So again, that means instead of going this direction, I'm going clockwise. And I just go ahead and drop down 50 degrees. So I'm still in that quadrant here. And that is my terminal side. That little gap from the x-axis and the positive down to that line, that is the angle measure of 50 degrees. And I'm saying it's negative to tell you what direction I am spinning. So in this set here, we want to go ahead and now draw the angles ourselves in standard position. And this time picking stuff that is not directly from the book, so you have some other examples. So this one says to draw an angle of 300 degrees, so that's the measure we want to use. For it to be in standard position, we know we're going to go ahead and have to start here. Now, to be positive 300, it means we will have to go counterclockwise. So I want to spin this direction, meaning I get to use these numbers up top here. 0, 90, 180, 270, 360 is going to be over here. So basically, I'm looking at this here. I'm tracing along this direction, so you know that I'm using my initial side as the positive axis. Here's my vertex, and I want to spin from here all the way around until I get to there. That full angle will be 300 degrees. Now you might say, well, how do I know exactly how far past it am I going? Well, come back to here. We know that this here is 270. If I'm trying to find out how to get to 300, I'm basically saying 300 minus 270. Well, that gap then is going to be 30 degrees. So from this line to that angle, that gap there is an additional 30 degrees. which means this gap over here is 60. But again, what this tells us is that I'm spinning this direction, and that will be 300 degrees. In this one over here, it says we want to use negative 120. So what I have marked right now are the positive versions. All you have to think about is that each gap is 90. If I'm going to go to negative 120, I'm going to 90 and then a bit farther. I'm going to be in this one over here. So again, 90 and then a bit farther. So let's come down to here. And again, here is my initial. I'm going negative, so I've got to go clockwise this time. I'm coming this direction here. So I go that direction. I have now gone negative 120 degrees. And again, to talk about that gap, well, think about what just happened here. We just covered 90 degrees. So there's two ways to do it. One way is to say negative 120 plus 90 to talk about me still going an additional 30 degrees. Or you can just think about it in terms of absolute value and say 120 minus 90. But still is talking about that 30 degrees. As long as you understand that I'm talking about this portion of the angle right here, we can go ahead and label this portion as 30 degrees. But yes, that negative would tell us what direction I am turning. I'm turning clockwise in this case. For this last one here, negative 450, what's different about it again is that that number is larger than 360. I'm spinning full circle and then a little bit more. So here's the way I recommend thinking about it. I'm going to do this one while still using the negative. So again, in this one, I said 120 minus 90. Let me write down below it the other way you could have done it. You could have said negative 120 plus 90 to get negative 30, which again would tell you that you kept going clockwise 30 degrees. I'm going to use that method for this one over here. And that's because I really want you to see what's happening with the negative 450. And let me use blue. So I'm going to say that I'm starting with negative 450 degrees, and I want to kind of eat up one of those circles. And I'm going to eat up one of the circles by adding 360 degrees to that. So let's come through here. Again, really what I'm saying is negative 450 plus 360 is oops, let me get that there. It's negative 90. So negative 90 degrees. So what's this telling us? It's saying that I went full circle in the clockwise direction and have enough left over to get back to here. So just go ahead and show that here. Again, here is my initial side. So I'm starting here. I am going full circle, and then I'm kept going until I landed right there. So that whole thing overall is communicating negative 450 degrees. And again, what I'm showing here is that I went a full circle. Notice that when I drew this little circle, I went all the way around it. So I started here and I ended there, but I kept going another 90 degrees. And that's what this negative 90 tells us. Negative 90 took us to this position right there. So here are three of the angles: 300, negative 120, and negative 450. So any two angles that have the same terminal side are going to be called coterminal angles. Think about the phrase like, I'm going to be cooperative, or just the word cooperate in general. Co means to share. So they're going to share that terminal side. Now if we come back up to here, again, that terminal side, it's where it terminates, it's where the angle ends. I could think about an angle going this direction, or even one going that direction. They end on the same side, so they would be coterminal. So we have some examples of that right here. So in this one it says, find one positive angle and one negative angle that are coterminal with negative 45 degrees, and then over here, 395. Well, this is really easy. Just think about how many times you're spinning full circle. So let's say I'm starting with negative 45. I could add 360 to it. I get 315. So if I look back at my picture here, I'm showing that I am spinning 315 degrees in the positive direction. Or I could say, let's start at negative 45, take away 360. I'm going to spin clockwise then, a full circle. Regardless of how many times you spin full circle, you're still going to end back up on that same terminal side of the angle that referenced negative 45 degrees. Now, I can do the same thing for 395 as well. I can take away 360 here. So again, look at this part here. This is where 395 was. If I take away that 360, I'm really just discussing this 35 degrees right here. If I take away 360 again, I'm now going to have a negative value showing that 325. So basically, it's two ways to talk about it. A positive version and a negative version are still referencing that same angle of 395 degrees. So let's go ahead and walk through some examples for that. So we're going to try the same thing. Let's find one positive and one negative coterminal angle. Let's do the first one for 80 degrees. So I'm going to do the first part by doing 80 plus 360. Again, I'm saying I'm going to go up one full circle. So 80 plus 360 is going to get me 440 degrees. Let's do the other direction. Let's take away 360. Spin the other way. Full circle. 80 minus 360. And that is negative 280 degrees. Let me draw a little sketch also so you can see what's happening here. So 80 degrees is really right here. So this whole thing here, that is 80 degrees. So let's say let me do a different color. Let's use green here. So let's say I'm doing the top one. So that means I'm starting here. I'm going to go all the way around and come back here. That represents the 440. Let's say I went ahead and pick a different color here. Let me use light blue. So then let's say, again, I'm now talking about that full circle from there. And for the other version, let's go ahead and take a look at negative 280. So that one can be shown. Let me see, I'm starting here. And then again, going clockwise is negative. So if I go to here, that whole thing is negative 280. So same angle. Let's do the same thing for this one over here. Notice that 740 is so large, I don't have to add 360 and still stay positive. I can subtract 360 and still be positive. So I'm going to do that because I'm going to do that anyway in order to get to the negative portion. So let me use red. So I've got 740 minus 360, and that's going to get me 380. Okay, so I could use that as my positive angle. That would be perfectly fine. Or I could actually go down again. I could do 740 minus 2 times 360, and I'll be left with 20 degrees. Again, at this point, I could use either one of these, and it would be fine. Let me do 740 minus 3 times 360. Now I'm doing it a third time because otherwise I'm not going to get to a negative value. So again, this said 740, take away one full circle. If I take away 2 circles, I'm still positive. I'm at 20 degrees. It's the third circle. That's when I actually get into the negative values. And that'll get me negative 340 degrees. So let's go ahead and draw that. Okay. And for this, you know what, I'm going to use this one here just because it's much easier for us to think about things when they're in that angle that's less than 360. So coming over to here, this amount right there, that is my 20 degrees. So that went positive version. For my negative version, let's look at this one here. I'm going to spin all the way around to right there, and that is my negative 340 degrees. So positive version, negative version, all talking about the same angle, 740 degrees. Because again, these angles are coterminal. If I spun it around, let's see, if I spun it around from here 2 full circles, it would still be 740. And lastly, we have negative 135. So I'm going to do negative 135, take away a full circle. So minus 360. And I'm going to get negative 495 degrees. going to go ahead and do negative 135 plus 360. So again, a full circle, but this time the other direction. And now it's going to get me 225 degrees. Let's go ahead and put this down. So I'm going to do that positive version first. So again, 90, I have 180, 270, 225 is over here. So the angle, swap colors here. The angle from here to there, that is 225 degrees. For this one, it's saying go around a full circle and then keep going some more. So if I start here and I go all the way around and I come back and I land to there, that is negative 495 degrees. So now we have some examples of finding coterminal angles. Again, there are two sides of the same coin. In this case, they wanted a positive version and a negative version. But if they just said coterminal and nothing else, you could pick multiple positives, multiple negatives. It just means that they reference the same angle. And lastly here, I want to talk about other ways to measure angles. Up until now, we've only talked about degrees. You might remember from geometry that we have something else called radians. So think about a circle with a radius r that's going to be centered at the origin. So just a normal circle centered at the origin, radius is some value r. Well, a radian is the measure of an angle in that standard position whose terminal side intercepts the arc of length r. What they're saying here is that the radius is along the arc length. So the special value for the radian. Another way to talk about the radian is that it's going to be the value left over when I do circumference divided by the radius. Now, the units of radians are sometimes labeled as radian or perhaps rad, and sometimes they're not labeled at all. So here's a tip. If you're talking about an angle measure and you see the pi symbol and you haven't had any notification that's going to be in degrees, it means that you are really working in radians. So you might see something like the angle measure is pi, or perhaps pi over 4. That means you're really working in radians. So a full circle, well, we already know that's 360 degrees. In terms of radians, it's 2 pi radians. So if the full circle was 2 pi, half the circle is just 1 pi, which means that we can use the information that 180 degrees is just pi. And we're going to use that when we want to convert from degrees to radians and back and forth. This also means that your calculator will need to be in radians if you're using radians in your question. That, or you're going to have to convert your radians to degrees. Although the scientific calculators I've given you guys links to can work in both. So, if I have to convert between degrees and radians, let's say I'm starting in degrees, all I have to do is multiply by pi radians over 180. If I want to go radians to degrees, multiply by 180 degrees over pi radians. And I'm going to show what this looks like in just a moment. If you prefer using proportions and ratios, you can also do that, and I'll give an example of that as well. For this first one, we're going to look at converting from degrees to radians. Let's go ahead and start out with 120 degrees. So again, I'm going to show it to you two ways. The first way is to say that this is 120 degrees, and let's say I want to get it into radians. Let's call it new value n. So n equals whatever I'm going to find. You can call it x, y, I don't really care. N equals 120 degrees times pi radians over 180 degrees. And again, if you think you might mess this up, don't forget to do 120 over 1. That way you remember that you are going across the top and then down. So these degrees will cancel out. What I'm left with will be in the units of radians. Now this here, that's pi. If that doesn't look pi enough to you, go ahead and you can make that a bit more squiggly. So that's your pi. And I have 120 over 180. So coming through here, I have 120 over 180 pi. And my units are radians, whether I write down rad or not. I want to go ahead and simplify this. Notice that I can divide top and bottom by 60. So if I do that, 120 divided by 60 is 2. 180 divided by 60 is 3. So I have 2 pi over 3. That is the value in radians. So that's one way to do it. I'm going to show you another way also. So I'm going to go ahead and separate this. Another way of doing this is to say that I have 180 degrees over pi radians. Again, this is pi equals 120 degrees over x. That's the ratio method. Go ahead and cross multiply, butterfly method. I'm going to do 120 and pi, 180 and x. So I have 180x equals 120 pi. And again, when I'm doing this, do not multiply out the pi. I want pi in my final answer. Divide both sides by 180, and I have x equals 120 over 180 pi, and I say, oh wait, that is what I had right here. I already know. What I'm talking about is 2 pi over 3. So from degrees, the 120, I have answers in radians. You can write down the word radian, or you can write down rad, or you can leave it blank. Just know that when I have pi in that final answer, I'm talking about radians. So that's an example going from degrees to radians. Let's take a look at another one. So let me slide this up here. So looking at number 2 here, let's go ahead and do negative 40 degrees. And again, I'm going to show it both ways. Let's have n equal negative 40 degrees over 1 times pi radians over 180 degrees. Degrees will cancel. My answer will be left in radians. So I have negative 40 pi over 180. Notice that I can divide top and bottom by 20. Negative 40 divided by 20 is negative 2. 180 divided by 20 is 9. So I have negative 2 pi over 9. Let's do the same thing using my other method. I have 180 over pi equals negative 40 over x. Cross multiply. 180x equals negative 40 pi. Divide both sides by 180. And like we had last time, this simplifies to negative 2 pi over 9. Whether you write the word radian or not. I'm going to go ahead and go through now and box my answers. 2 pi over 3, negative 2 pi over 9. So again, what I've shown there is going from degrees to radians. I'm going to go ahead down here and show an example of radians 2 degrees. So radians to degrees, let's give this as example 3. Alrighty, actually let me color code this in black. There we go. So example 3, I'm going to start with negative pi over 12. So I'm going to say n equals negative pi over 12, and again this whole thing, this is in radians, times times 180 degrees over pi radians. So again, radians are in the top here, radians in the bottom there. These pi radians will cancel out. I'm going to end up with negative 180 over 12. And that can simplify. I can divide top and bottom by 2, for example. I'll get negative 90 over 6. And I say, oh, I can keep going. I can divide top and bottom by 3. So just keep going this way here. I now have negative 30 over 2. And I go, oh, wait, in the end then, I just had negative 15 degrees. So n equals negative 15 degrees. Let's do the same thing using the ratio method. I have negative pi over 12. Again, this top is my radians. So negative pi over 12 radians equals pi radians over 180 degrees. And as before, we're going to go ahead and cross multiply. So again, I'm using butterfly method. Come along this way, come along that way. Okay, so we have negative 180 pi equals 12 pi. Okay, so in this next one, I had negative. Okay, so for this next one, let's go ahead and label this part here. So for this next version of it, I'm going to take that negative pi over 12, but do it using the ratio method. Now, it might get a little bit confusing, so I'm going to have some notes on the side also. What I'm starting with is negative pi over 12 over some unknown amount, n, in degrees. This is going to equal pi over 180. So again, this is n degrees, that's 180 degrees. These are radians, those are radians. Okay, now notice that I have a fraction over a fraction, which we're actually going to go backwards to teach in a little bit here. So I'm going to show you what I want to do with that off to the side here. I'm going to show it over here. And I'm just going to talk about this part right here. So I'm going to separate that. Think about this as saying negative pi over 12 divided by n over 1. Okay? So negative pi over 12 divided by n, or n over 1. Now, dividing by a fraction is the same thing as multiplying by the reciprocal. So times 1 over n. Notice that let me make this a better pi. There we go. Notice that that n is on the bottom. So I can write that part as negative pi over 12n. That's what I'm going to use. So kind of come back here. That is what I'm going to use in place of this. So I have negative pi over 12n equals pi over 180. Now I'm going to go ahead and cross multiply. Negative 180 pi equals 12 pi n. I'm solving for n, so go ahead and divide both sides by 12 pi. The pi's will cancel, and negative 180 divided by 12, well, from our work here, that's negative 15. So n still equals negative 15 degrees. So again, the ratio method is better sometimes over others. This is one time when ratio looks a little bit more confusing, but it still works as long as you are okay with fractions. Let's go ahead and do another one of that same type. So looking at number 4, I'm still doing radians to degrees. So for this one, let's take a look at 5 pi over 4. And again, I'm going to show it both ways. I'm going to show it using the decimal multiplication method as well as the ratio method. So let's say I'm going to use the multiplication method. I'm going to have n equals 5 pi over 4. And again, that whole thing is radians times 180 degrees over pi radians. Okay, so what I've got here, my pi's will cancel. N equals 5 times 180 over 4. That whole thing will be in degrees. Well, notice I can do 180 divided by 4. So again, come back to here. 180 divided by 4. That gets me 45. So this part here is 45. So n equals 5 times 45, 225 degrees. So n is 225 degrees. That was the multiplication method. So again, here I said 180 divided by 4 to get myself to 45. I then multiplied by 5 to get to the 225. Go ahead and separate that here. Let's go ahead and do the ratio method. And like the last one, it's going to be one of those fractions within a fractions. So I'm going to start with 5 pi over 4 over n equals pi radians over 180 degrees. And yeah, technically n is in degrees as well. And again, off to the side here, I'll show my little scratch board work. I'm thinking of this as saying 5 pi over 4 divided by n. Remember, dividing by n is the same thing as n over 1. And dividing by a fraction is the same thing as multiplying by the reciprocal, 1 over n. Meaning what I have is 5 pi over 4n. That is what I'm going to use. So I have 5 pi over 4n equals pi over 180. Go ahead and cross multiply. So I'm going to have 4 pi n equals 5 times 180, 5 times 180, pi, that is a pi symbol. Go ahead and divide both sides by 4 pi. Notice at no point in time am I actually multiplying the pi out. Pi will either stay in my answer if I'm converting from degrees to radians, or pi will be gone because it cancels out entirely. So again, the 4 pi's are gone over here. I have n equals. These pi's are gone over here. I have 5 times 180 divided by 4, and I go, oh wait, that's what I did over here. Therefore, n is just 225 degrees. No matter how you spin it, that's the same answer that you are going to get. So, in this section here, we've covered how to convert from degrees to radians and radians to degrees. Lastly, what I want to mention is that if I think about what's happening full circle, I can convert any of those degree measures to radians. So what I have here, so this picture here, will be extremely important in pre-calc and calculus. And all these numbers on the outside, those are the radian measures, because I can take any angle measure, multiply it by pi over 180, and get out the radians. So just be aware that this exists as well. And we'll be using it in the future with something called the unit circle, which is basically a special circle centered at the origin with a radius of 1. And all of these values here, we're going to be using our trig functions to analyze these values and find out how to plot them using xy coordinates.